Alright, whiteboard review. CIS-125. Actually day 3. This was Wednesday of the second week. So we only had one day in the second week. In the course we were talking a lot about background, just some basic IT background most people are familiar with. Talk a little bit about coding. We're working on some coding using Python. The syntax, you learn how to write the language, but what's really important also is being able to design so the code runs efficiently and so forth. So we've been talking about design. Start talking a lot more about that this on that upcoming Monday, which I've got a whiteboard review. Okay. Do that in class, and then we'll follow up with whiteboard reviews. We talked a little bit about that focus on learning. I talked about being some students grade driven, some students task driven. Everyone, even if they're part of this and part of this, everybody should be knowledge driven. You should strive to learn. Shouldn't be afraid to give the wrong answer. Okay? Because wherever you're at, you want to go this way in terms of learning. Okay? And then, FYI, the 7-Elevens. I asked how many students have heard of 7-Elevens. They were a convenience store back when I just got out, when I was in college, actually in college, and just got out of college. They became real popular. They still have them in Indonesia. And there, what they do is they become a gathering place for people because of they have free Wi-Fi and people can sit around. They, have snacks and stuff to eat, and it just becomes a place to congregate. Well, what they've decided to do is now they are teaching coding there. A lot of mothers are going in the evenings and getting some coding classes so they can supplement their income, JavaScript, web design, and so forth. So it's kind of a cool story how that's really catching on in Indonesia. Alright, you can't be a coder if you don't understand the binary number system. Some people get away with it, Binary number system, bits, binary digits, okay? Binary digits, that's where the word comes from. So I don't know if it's, B in the IT or if it's, whatever. But that's where bits, ones and zeros. We talked a little bit about the ASCII code. You have some arrangement that represents, in this case, text. And then we talked about rearranging that. Like if you're going to, encrypt something, you can have a certain pattern or an algorithm that rearranges the bits and then rearranges them and converts them back if you want to encrypt information. We'll talk more about algorithms here in a little bit. That's actually on another part of the page. We should be able to distinguish in the fact that we use an arrangement of ones and zeros to represent text, and we'll use a different method to represent numbers. So we'll talk about strings of information or text. Some of that goes way back in time. We'll talk about numbers, or often referred to as numerics. And then we can store pictures, voice, slides for video, and so forth. But these are the two right away we want to try to understand in terms of technology. Moving. Some real important things here. Okay, so we talked about, you can't probably see that, we talked about software. We talked a little bit about accessing the work servers. And then we re-emphasized that these numbers are really groups of bits. They're really groups of bits. So they call them these octets for an IP address. And then here we refer to the private address and the public address. But they're really just a large number of bits representing that address. Arithmetic logic unit, basically computers can do arithmetic, make logical decisions, and manage that information inside the processor. Move it along an electronic bus between there, and then also we have storage. I didn't write that in there before. Storage, memory, and processing. We'll refer to that a lot. So we have this hardware that we need to communicate with. What communicates? So we have what we call system software. Communicates with the hardware. Two levels of that. We have the operating system and we have utilities. You should be familiar with some operating systems like Windows and Linux and iOS for Apple and Android and so forth. Macintosh has their operating system. Utilities are things like some kind of file manager, virus software. The utilities allow you to check memory and so forth on the computer. Maybe set up users and so forth. So these are the two main system software we use. And then what communicates with the system software are applications. Applications are designed to function with a particular operating system. So when we talked about this earlier, we take a source code, and when you compile it into an executable code, you would use a compiler that matches up with the particular operating system that the executable code is going to run on. You can compile it so it runs on Windows. You can compile it so it runs on Android. You can compile it so it runs on Linux or iOS and so forth. Okay? To get the source code, we have to have some type of design, and we overemphasize that idea. We can create source code using Notepad. We're going to be using VI a lot. We'll use that in Linux. That's a text editor. And we'll be using that quite a bit. And then way out here, using the app as the user. And we talked about the user interface and the user experience. Both very important to programmers. Very important. Alright. Flowchart symbols. We're working on those now in class. To programming. The design, the solution to the problem, and then eventually we can design a program to do that. Most important thing when you solve a problem is you have to be able to define the problem. What do you want for a solution? What do we have to put in to get that solution? And the key that happens in between there to go from here to here is we have the process. Software. Programs allow that process to exist. So we will refer to often in the course IPO. What are you going to put in? What do you need out? And how are you going to process it? If you can't figure this out by hand to start with, it's pretty tough to define or to design a program to do that. You might think of this a lot of times as we have data here. Put the data in. We can process that data. Now we have some valuable information. You can put in how many hours they worked and etc. here. Process it, and now we have pay. You can put in somebody's birth date, process it, now we know how old they are. That might sound a little crazy, but that's really true. Those are simplistic examples, but I better keep moving. Programs are like algorithms. They are algorithms. We're going to do an example here, the division algorithm. So I asked the students, if we had 24.8 and we want to divide that into 5 parts, what would you do? And they said, well, you divide it. So I had them explain how to divide it, and they said, well, you divide it. You take 5 into 24. What do you mean 5 into 24? And he says, well, and finally one of the students said, well, you have to make a division symbol. You've got to put this number on the inside. You've got to put this number on the outside. Some students said you got to move the decimal up right away. Some others didn't. But then you see if 5 goes into 2, it doesn't. 5 into 24, it does. 5 times 4 is 20. And here, and you subtract. Then I have 4, bring down the 8. Now you repeat the process. So you gave it a group of steps, and now we're going to repeat them until something causes us to be done. So we go 5 and it doesn't go into 4, it goes into 48, 9, 45, we subtract, bring down to 0, same thing, 5 doesn't go into 3, goes in there, 6, anyway, so we get the answer. Division algorithm always works. Couldn't be an algorithm if it didn't. And you notice the process repeats, so you can put a certain set of instructions and then repeat them until something is met, and then we finish up. That is how program basically. So here's an overview of the whole thing. We talked about algorithms and how they work. Everything's represented in bits. We have this whole in, out, in process and out. We have to solve a problem, you have to define it, then you have this whole process. Key is what instructions to process it. We talked about computer hardware and what communicates with the hardware, system software, what communicates with the system, apps, and the user communicates with the app. So you can see how people become very a typical user may not really understand what's all going on in this process. User interface, user experience. How do we get software? Design, create code, compile or interpret to object code, link that in the executable code that runs on some particular operating system based on what compiler you used. We can create this using Notepad to create the software. This little bit in here, we're talking about bits over here. I remember in class, we're talking about bits here. Then I went over here and I gave an example that these addresses here are really just a whole bunch of bits that the computer interprets. So, next big step is understanding design and control structures. Some way to show a path or some way to convey information on how you're going to solve a problem. And we'll talk about those next. That's it.